Okay, this is Mr. Ellis, and we're going to talk about Earth history this time. We're actually going to be a little bit different. We're just going to have one set of notes for these next two sections. So let's get started. First off, fossils. Y'all have all heard of fossils. That's when you talk about dinosaurs, their remains. It could be dinosaurs, any other ancient organism. It could be people. It's usually preserved remains or evidence of an organism that lived in the distant past. A lot of times they can be actual bones, or maybe they might just be the footprints. Sometimes they can be the waste, the droppings of a dinosaur. Okay, it could be the evidence that it was there. And here's a good question that I always use. Fossils are normally found in sedimentary rock because metamorphic igneous all involve magma and heat, so they wouldn't actually last over time. So most of the time, 99.9% of the time, fossils are found in sedimentary rock. That's going to be an EOG question. Extinct, that's when there's no more individuals of a certain species alive on Earth. The dinosaurs are extinct. Dodo birds are extinct. And there's other animals that have become extinct, and plants also that no longer live. Ice cores. Now, it's a cylinder of ice that's removed from an ice sheet near the poles, either South Pole or North Pole, Antarctica, or the Arctic. It takes out a piece of ice, and it gives us evidence of climate. So that's the big thing. That second bullet, that's the big thing. When you're talking about ice cores, it always tells us about ancient climates. And it's almost like layered, kind of like tree rings, except it's like rings of ice. And so they trap air bubbles. The air, they get frozen. And if it's more oxygen bubbles in the ice, then that means that was an age where it was very cool, almost like maybe possibly an ice age. If there's more carbon dioxide bubbles in the ice core, then that means at that time of history it was warm tropical climate. Okay, more hot climates. Now, geology, that's the study of Earth's history, processes, and structures. Y'all have been doing geology since sixth grade when you talk about volcanoes and rocks. A lot of stuff we're talking about in this section. And you're going to do in the coach book is some reviews from sixth grade with plate tectonics, volcanoes, all different types of faults, and the three types of rocks, the rock cycle, that kind of stuff. Okay, now absolute age. This is the actual age of a rock or a fossil. So if that's your absolute age, we normally use some kind of radioactive dating, uranium or carbon. The Earth has been aged scientifically to be 4.5 billion years old. Okay, so that is the scientific age of the Earth, of the rock that's in the Earth. Now, radioactive dating is where we find the absolute age of these rocks or fossils. Like I said, carbon-14 is what we use to measure things that were once alive. Like if we were to measure human beings or animals, we would use carbon-14. Plants, wood, those are things that were once alive. Okay, and it's usually those things 1,000 years old. Whereas uranium-235 is what you would use to measure rocks, and that's how they figured out the age of the Earth. Okay, and it's usually millions of years old instead of thousands of years old. So know the two differences. Now, the relative age is when you compare it. Kind of like when I say, talk about teachers. For instance, y'all all know I'm older than Miss Waters. Okay, but yet I'm younger than Miss McCullen or Miss Wood. Okay, I'm not giving you the actual absolute ages, but we're giving you relative ages. And this is usually, we do this with something, a law called the law of superposition. And what it means when it's undisturbed, there's no earthquakes or plate tectonic shifts in sedimentary rock layers, the older rock layers at the bottom and the younger layers at the top. That makes sense. If you got your dirty room, okay, and I know some of y'all throw your clothes on the floor. Well, guess what? You throw your clothes in a pile or in a dirty hamper, even though you throw your clothes in a dirty hamper. The clothes that you wore last should be at the top, whereas the clothes that you wore longer ago are at the bottom. Unless you're like my little brother and like to go looking in the dirty clothes hamper to find something to wear. He was bad for that, let me tell y'all. Okay, so earthquakes and volcanoes, they can disturb the rock layers, and they make this law untrue. So if it's been jagged and messed up, earthquakes, plate tectonics, that kind of things, fault lines, then this is not going to work. Now, intrusion. Intrusion is a disturbance in the horizontal rock layers, like sedimentary rock layers. It's usually caused by lava coming up from the bottom, magma coming up through the bottom, and it kind of cuts into the existing rock. And the intrusion is always younger than the rock it intrudes into. Okay. Now, index fossil. This is a type of fossil that existed, and this is one of these key words because it's going to be on the EOG. It existed for only a short period of time, but you can find it all over the world. Okay. One big example is a trilobite. They only lived during a certain time period, and they were all found all over the earth. And if you find a fossil and it's in the same layer of rock as a trilobite, you know that it was around that same time. And there's all kinds of different index fossils. And I just mentioned trilobite. That's usually one of the main ones they use as an index fossil. And I've got actually one I'll show y'all in class. I actually have a cast model of one of a trilobite. It's like a little bug, and you've seen them before in all your prehistoric videos or prehistoric pictures and that kind of stuff. So you would probably see one of these before on a picture. Now, the geologic timescale. That's the timeline that organizes the major events in Earth's history. Now, we're not talking about history like y'all do in Miss Waters' class. We're talking about history like eras, okay? Because humans, we've only been here like a tiny fraction of the time, okay, the Earth has been around. We've not been around 4.5 billion years. So I'm going to the different things. And you're not going to have to memorize all these. It's just good to know them. You know, the eon is the longest unit of time. There's 4 eons. An era is then divided into eras. And these are unit of time divided by mass distinction. Should be extinctions, okay? Because there's been lots of times where, like y'all know, the dinosaurs became extinct, where a bunch of things were wiped out. There's been 4 or 5 of those, okay? Something says to me in that data. I ain't gonna worry about it. Oh Lord, what happened? Oh, there we go. Okay. So a period is a block of time where unique rock layers were laid down. Then an epoch or an epoch is the shortest division of geologic time. Like I said, that's just something for y'all to know those words. Precambrian. This is the earliest eon of Earth's history. This is usually where a lot of one-celled life forms lived on Earth. Humans were around, animals, plants were around, a lot of bacteria. Okay, we don't find fossils of these because they didn't have bones, and you got to have bones to have fossils. Okay, so there were no fossils in this area. The Cambrian was a period of explosion of life composed of living cells. So this is when everything started getting together. We started having more life. The Paleozoic era is the era of amphibians and early land creatures. They were crawling out of water and getting on land. That's the Paleozoic era. The Mesozoic era is the dinosaur. And you've heard of Jurassic Park, like Jurassic, the Triassic period. That's where your dinosaurs come from. Then you have the Cenozoic. That's the age of mammals. That's what we're living in, okay? And these are actually the ones we're living in: the Phanerozoic eon, the Cenozoic era, the Quaternary period, and the Holocene epoch. And you'll see a little diagram in your coach book that shows you all these eras. And like I said, you don't need to memorize these. It's just something for you to know. I would know that Cenozoic is mammals, Mesozoic's dinosaurs, okay? And that's pretty much it. I'll pause it. I'll put some video playlist on the video playlist that was watching class. I'll also put it on here somewhere, okay? Y'all take